Okay, so this topic, factoring and solving, the title is not intended to mislead you. It is exactly what you have done before, and in so much as you've done this last year, but we have actually done the bulk of this year, and when we talked about and discussed factoring. It's really no different than what you've already done with factoring. It does take it one more step beyond just factoring. So if you struggled with factoring before, I'm just going to tell you right now, you're going to have a lot of trouble with this. If you have not gotten the help you needed regarding factoring, then you need to come see me. Plan on it. Don't wait, because this gets really cumbersome as the year progresses, as we do different things that involve factoring, that if you don't have those foundational skills, this will be a lot of trouble. Today's really isn't much different than factoring as we did before, except it just adds a step. So when you look at a problem like you see here in front of you, cosine squared x minus 3 cosine x plus 2 equals 0, a couple of things should stand out to you. One, that you have cosine squared. You have a squared trig function. And just like when you see x squared, we're going to think, can I factor this, or can I take the square root of it, or what can I do with this? So the fact that it has another cosine in this equation tells me that yes, in fact, I'm going to probably have to factor. And so in looking at this, just like in our steps of factoring, the first step is to ask yourself, what multiplies to give you cosine squared x? And of course, it's pretty simple to think, okay, that's cosine times cosine. At least my hope is. And then you ask yourself, what multiplies to give you 2, and at the same time adds to give us negative 3. So, of course, the only thing that multiplies to give us 2 is 2 times 1. This last sign tells me the signs are the same, and this tells me here in the middle that they both must be negative. And so that's how we factor it. Then, just like before, you set each part equal to 0, and you solve. So I'd have cosine x minus 2 equals 0. So therefore, cosine x equals 2 on the left. On the right, you have cosine x minus 1 equals 0. And so therefore, cosine of x equals 1. And we're not quite done, because we haven't solved for x. And this is the part where it takes it that next step. Usually at this point, x is already alone, and we're good to go. But because of the cosine function being present in this, we have to actually address it. Now, the question then is, back to our arc question, when does cosine equal 2? Think about that. When does cosine equal 2? If I was to look at the graph of cosine, I'll just draw a little mini one here. How high and how low does that go? 1, right. And so if it only goes as high as 1, when does it ever equal 2? Never. This is what we call reject. We can't do that. It will never equal 2, unless we obviously have a different coefficient in front of that cosine, but that's a different thing entirely. Now let's look at this one. Cosine x equals 1. When does cosine equal 1? Well, look, coming back to this graph, you can see cosine of x equals 1, not just one time, but actually 2 times. It happens at 0, and where else? Good, 2 pi. And so my answer to this question is 0 and 2 pi. All right, let's look at the next question. Cosine squared of x equals 1. Now this one only has cosine squared of x. So just like if this said x squared equals 1, I want you to understand that we don't want to factor if we don't have to. Now certainly you could. You could, and I'll do this off to the left here, cosine squared x minus 1 equals 0. You could do cosine of x and cosine x and 1 times 1, and the signs are different, and you could solve this. Or option number 2, cosine squared x equals 1. How do I get rid of a square? Square root. But we remember, at least I hope you remember, that whenever you take the square root of a function, you get plus or minus. And so the question then asks, when is cosine either positive or negative 1? And so back to the graph that I have drawn in the first example there, we can see that cosine is positive 1 at 0. It is negative 1 at pi, and it is back to positive 1 at 2 pi. And so my answer to that would be 0, pi, and 2 pi. And the same would hold true for this left-hand side. It's just that it would have written it separately. When is cosine equal to positive 1, and when is cosine equal to negative 1? So it's just separating those two. Again, you get the answer 0, pi, and 2 pi. All right. right, the last example that I have for you is, what about this one? It may not be quite as obvious as the one previous there, where you have cosine squared x equals 3/4. And you look at that and you're like, oh, I don't want to do that. But certainly if you were to bring it to this side and you have cosine squared x minus 3/4 equals 0, and you're going to try and factor that, it's not quite as obvious. And so I would recommend that when possible, if you can do the square root, then do that, because it makes things a little bit nicer as you're approaching this question. So when I do the square root, and it may not look nice yet, but it will, you hit cosine x on the left, that's kind of obvious, and you get, again, plus or minus the square root of 3. What's the square root of 4? 2. Now, does that number look familiar? Hopefully it does. Hopefully you're thinking of your chart right away and you're like, oh, square root of 3/2, that's in my chart. And we know that with the cosine that it's, of course, pi over 6 angles. And again, it's saying plus or minus. You can see that if you forgot the plus or minus, you actually would eliminate 2 of the answers here. So we got to be careful about that. But this is saying plus or minus root 3/2. So I know this is a pi over 6 angle, and I actually want all 4 quadrants, because that's what the plus or minus basically is indicating. And so I would have all 4 pi over 6 angles as my answer there. Okay, so the plan from here on is for you to finish up the homework packet part that you were assigned today during class, if you didn't already finish that. And then tomorrow we'll be practicing quite a bit of how to solve using factoring.